Hello, welcome to the fourth lecture on electric charge and electric field. In this video, we will discuss about the net force and the net torque experienced by an electric dipole placed in an electric field. This dipole minus q and plus q is placed in a uniform electric field E. The minus q charge experiences a force opposite to the electric field. Plus q charge experiences a force in the same direction of the electric field. Let's consider the electric field is along x-axis. A proton placed here having positive charge experiences force in the same direction of the electric field, and electron being negative, it will experience the force opposite to the electric field. How much is the value of the force? Since E is equal to F by Q naught, F is equal to Q naught into E. Thus, the force experienced by a charged particle is equal to magnitude of the charge into the strength of the electric field. Now, the force experienced by plus Q charge is F1. Thus, F1 is equal to plus Q into E vector. Similarly, force experienced by minus Q charge, F2 vector is equal to minus Q into E vector. Thus, the net force experienced by the dipole, F net, is equal to F1 vector plus F2 vector. That is equal to QE plus minus QE is equal to 0. Thus, the dipole placed in a uniform electric field experiences no net force. That is, it is in translational equilibrium. If the electric field is non-uniform, that is, the value of the electric field at point A is not equal to the value of the electric field at point B. That is, F1 and F2 values are different. Then the dipole will experience a net force. If the electric field is non-uniform, the dipole will experience a net force. One net torque experienced by the dipole. Those two charges experience forces F1 and F2, which are equal in magnitude, opposite in direction, act along different line of action. So they constitute a couple. The tendency of the couple is to rotate the system. Thus, the net torque experienced by the dipole will tend to rotate the dipole. Here, the dipole tends to rotate in clockwise direction. What is the value of the torque? This force F1 and F2 can be given. Net torque is equal to force into perpendicular distance between the line of action of those two forces. To find the perpendicular distance between the line of action, here F2 acts like this, F1 acts like this. So ABC, the triangle, BC is the perpendicular distance, and the length of the dipole is given 2a. Theta is the angle. Theta is the angle between the dipole moment and the electric field. Thus, sin theta is equal to BC by AB. So, BC is equal to AB sin theta. AB is equal to 2A. So, BC is equal to 2A sin theta. So, this is the perpendicular distance between the line of action of those two forces. To find the torque, the value of the force or the value of the perpendicular distance is put here. The value of the force is equal to QE, because F1 mod is equal to F2 mod is equal to QE. The perpendicular distance value is equal to 2a sin theta. Putting these values, it is QE into 2a sin theta or 2AQE sin theta. 2AQ is equal to P, dipole moment. Thus, the torque experienced tau is equal to PE sin theta, where theta is the angle between P vector and E vector. Tau vector is equal to P vector cross E vector. That is, the torque is the cross product of the dipole moment and the electric field. The direction of the torque is perpendicular to the plane containing P vector and E vector. Let's consider some special cases. That is, the dipole is placed in such a way that the dipole moment is along the direction of the electric field, or the dipole moment is opposite to the direction of the electric field. That is, theta is equal to 0 degree or theta is equal to 180 degree. The torque experienced tau is equal to PE sin 0, that is equal to 0, or PE sin 180 degree, that is also 0. Thus, a dipole aligned along the electric field experiences no net torque. Case 2, if theta is equal to 90 degree, then the torque experienced tau is equal to PE sin 90. The dipole moment makes an angle 90 degree with the electric field. The torque experienced tau is equal to PE sin 90 is 1. So it is equal to PE, that is maximum torque is experienced. Thus, in this video, we discussed about the net force experienced by the dipole placed in a uniform electric field, placed in a non-uniform electric field, the torque experienced by the dipole, and the torque experienced when the dipole is aligned along the field, when the dipole moment makes 90 degree with the electric field. That's all. Thank you.